All right, so in my last video, I was messing around with Pest, a peg parser, and I would show how you can do stuff with it. And I was also following a book, and the book wanted me to implement like a toy language. I've more or less implemented that toy language, and I want to show you basically how you go about making your own programming language in Rust. Let's get it. All right, so I'm going to start off this video by going over the expressions that I wrote in the last video, just briefly, and then talking through the approach I'm going to take when I come to trying to evaluate them. And then I'm going to go through some of the test cases I have so y'all can see the evaluation and how it runs. All right, so if you recall correctly in the last video, I went over some of these expressions. As a quick overview, here's a program. It's filled with expression or a expression. An expression is the list of these expressions, which is evaluated in this order. And then these are those expressions. And then at the root of some of these expressions, or all of these expressions, is either a number or identifier, right? And then as an example, if you're trying to evaluate an expression, you can type it here, then pick the rule, which I picked this rule because that's going to be my top level rule. And then in this example of at least this expression, the let expression, we have let variable equal 42 in diff expression minus variable 30, right? And you can see when it comes to its output, it gets evaluated like this. First, it realizes that it's a program, okay? Then it realizes, a program evaluates to an expression. Then it realizes what type of expression it is. It's a let expression. And then it starts going through like the different parts of a let expression. And you know that a let expression has this part, and this part, right? So we come down here and we see that the let expression has these three, which are all indented at the same level, which is important. Variable, then it has an expression, number, which is 42, then it has an expression, and then that's a diff expression, and then you see another nested level with what corresponds to a diff expression. And if you scroll up here, we see that is expression, so it has two things in it. Expression, you notice that it's identifier, variable, and you know it's expression down here, and it's a number, 30, right? So when you see this program and see how it evaluates, you start to get the sense that you can't evaluate it until it gets down to the root items. As in, you can't evaluate till it gets all the way down here. And you figure out what variable is equal to by looking into an environment and then looking up that like value for that number, or looking up the value for that placeholder. And 30, which is a number, which you could just start passing back. And then once you pass that back, you could evaluate what the diff expression equals to. And that should be fine. Yeah, that's about it in terms of this expression, because the variable is set here. So this gets added to the environment. And then in here, this is going to be 42, which we looked up here, and then evaluated that. And that gives us the answer. So this is pretty straightforward. Anyway, more or less, I was trying to get to the idea that to evaluate this, you really have to go from the bottom top, unless you have a situation like this where you have to put something into the environment early on so that you can properly evaluate it from the bottom to the top. And anytime you think of bottom to the top, at least anytime I think of it, I think of recursion. So more or less, I wrote a small program to recursively solve all of these equations, or at least these expressions. And let me walk you all through that real quick. All right, so I've opened my editor to the source code, and I think I'm going to walk y'all through backwards because that might make more sense just to see how it evaluates going through. And I'm going to do that by walking through some of the tests. So here's a test for evaluate number, right? We have our let parser. We're going to parse. We're passing in the rule, which is a program. I'm passing in 42, which is the string that's going to be evaluated. I'm creating an environment, which I'm going to glance over for now because we can come back to that. It's not really important for this example. But then I created a function called value of, right? And it takes in pairs, which is whatever the let parser returns, which should be like the list of all of the stuff we saw in the terminal, well, in the web browser, in the editor, right? And we're also passing in the environment, which in this case is empty, and we're glossing over for now. So let's go to value of. So here's value of, and it takes an expression, which you can see it's a pest iterators pairs, because we know that the let parser returns pairs. And then in here, I'm going to iterate over the pairs in the expression and then pass them to eval. So let's look at what eval does. And you can see the environment is being passed straight through. So this is eval, and it's a little longer, so it's going to take some time to go through it. But more or less, it takes in a single pair, which has a rule, all right? And the environment, which we're still glossing over. I have a call here just saying that it's been called. And earlier I said that we're going to do this recursively. The way we're going to do that is via a match statement. So we know that the program can have multiple rules going down, like we saw in this example. We start with a program, and then you see that it goes to the rule let expression, and then in the let expression, it could be a diff expression, right? So what we do here is we have a match statement on all the different rules. And if we see one of the top level rules, well, what we do is we do a into iter to get the next rule, and then we pass that into eval, which could be an expression, which could be a zero expression, which could be a diff expression, which could be an if expression, or let expression, a number, or identifier, right? Like all of the rules are here and defined. And we keep passing it down into this eval recursively until we hit one of the root expressions, which I guess should be, in our case, my case, number or identifier, because those are the only thing that pass back values, like hardcore values that you could actually act on. So in the case of a number, right? Let me show you my browser. Oh, I could just type 42. In the case of 42, we see that it's a program, which we know is an expression, and then it's a number. So the way that evaluates is we hit a program, and then we do the into inner to get the next expression, or the next part of it, and then we pass that to eval, and that's going to be a number. So then we scroll down to the match for a number. And I even printed out found number. And in here, I'm just going to take the expression as a string, which is just going to be the number. Make it a actual string, capital S. And then start returning that back up the stack. So let's run that test so you can see it. So I will run the test just for eval number. You can see I have backtrace set to 1 just in case something comes up. Test, have the path to the test, and then I have no captures. You can see the print statements, right? So if I run that, you see that we have evals called 1, 2, 3 times, and then we find the number. And the value 42 is just being returned, and this is just the empty environment stack, right? And if you look at the test again, what we really wanted is to have 42 as a string returned. Oh, I didn't talk about the return type. So for convenience for me, and the way I was thinking about it is if I was evaluating a language, right? Yes, a number is not a string. However, I would want to print the results of whatever evaluations that occur to the screen. And in order to do that, I typically would have to have a string. So I figured casting everything to a string before I return it would be fine. So yes, I'm returning a string and the environment. So let's look at another example, something a little bit more complex. Let's do a diff expression. This is eval diff expression, and we have this string, minus parentheses 10, comma 30. And let's put that into the editor to see what the output looks like. So we have a program, we have diff expression, and then in those we have number and number. right? And ultimately this will evaluate to like negative 22. And I have the negative 22 here as the assert for the test. So let's run this test and then sort of trace through it to see what happens. All right, so eval has been called a number of times, right? And at some point in time, it found the 10, and it returned the 10 up the stack. Okay. And then at some later time, it found the 32 and returned the 32 up the stack. And then seemingly some math was done, and we got the negative 22, which eventually just returned all the way up the stack. So let's see how that worked. So we already looked at how number gets evaluated, but let's look at the diff expression. And oh, look, it all fits into the screen. That's nice. So when we get into the diff expression, one thing that we know is by the grammar, we have at least two items that are always going to be here, expression 1 and expression 2. And I can demonstrate that or show that in the grammar. So here in the diff expression, it's defined by having at least, well, always these two expressions. So we can guarantee that they're going to be here, which is nice. So once we can guarantee that they're going to be here, we can evaluate them accordingly individually. So this is a recursive call for the first expression right here. And this is a recursive call for the second expression. So they can get evaluated as needed. One thing I know, at least that's specific to this language, is the only basic type there is, or primitive type there is a number. And as such, I can arbitrarily know that casting this to I32 should be fine. However, if you have different base types, then you're going to have to do something slightly different. But the general concept is here. So I'm evaluating the first expression, and I'm evaluating the second expression. And then, because this is a diff expression, I'm doing subtraction. I do expression 1 minus expression 2. And I format that to a string, and I pass it back up the stack. And that's how we got the negative 22s going all the way through. All right, so now that we've seen how a number gets evaluated and how, let's say, a diff expression gets evaluated, let's look at an identifier, because an identifier is slightly different than both of the previous cases because it uses something that's in the environment, which I haven't really spoke about. All right, so this is a test for when a identifier is being passed in and the identifier has a value in the environment, right? And I haven't really spoken about the environment because it's really not all that impressive. More or less, it's a data structure that you can use to look up values. In my case, I'm looking up values via a string. And I'm using a stack as opposed to hash maps because the book suggested it at one point in time. It sort of makes sense in terms of creating new environments and then having them associated to a call stack specifically, and then getting rid of them. Like, we can go into that another time if you're interested, but more or less it's an environment that I can use to look up values. And I have a string to an I32 mapping. The reason why it's a string is because I'm passing in variable names as a string. And the reason why it's I32 is because this language only deals with I32s. All right, so in this example, or this test, I have the variable, which is going to identify to an identifier. And then I'm creating the stack, empty stack. And then I'm extending the environment, which more or less means adding something to the environment. And I'm adding the environment variable to be equal to 42, right? So before we do that, let me open here just to show it real quick. So this is what we have. We have a program, expression, identifier, and identifier is going to be a variable. And based on everything I said, more or less once we get to this part, we need to be able to look up this variable within our environment. So let's go to the eval and look at the match statement. So when I get to identifier, I use the environment, and I call a method called imply environment. The reason why it's called apply environment is because, according to the book, there are times you want to do math on whatever value is passed back. So this is more or less just a lambda, and I'm just passing back the variable as is, or the value as is, without doing anything extra to it. Here's the expression, which I'm casting it to a string and then passing it in. At this point, it should be variable. And then if there is a value, then I am returning the value back up the stack. And if there is not a value, then I'm panicking because that variable has not been assigned. So let me run that so you can see it. And as you can see, eval, and then the return is 42, which is the thing that was in the environment. And you can see the environment is also being printed out the entire time. And the false case, I just have, what did I call it? Eval false. I have it panic, which is what it's supposed to do. And I catch the panic. So, still passing test. All right, so we've seen how things get evaluated down for like numbers, and we've seen an expression or like a function in the diff expression, and we have seen identifiers. So let's put that all together for one last check using a let expression, which kind of does both. It adds things to the environment, and then it does some evaluations based on the expressions that it sees. So let's go to that test. All right, so for this test, I have the program let save equal 42 in diff expression save minus 41. And the answer that should be returned is a 1. And the reason why this is slightly different than the other ones is, as I was saying before, save equals to 42 is adding something to the environment that is being passed for when evaluating this expression, the diff expression. And then here, when you get to save, you're supposed to be able to see the identifier, which is save, look that up in the environment, find that save is equal to 42, return it there, and then evaluate the diff expression. So let's run that so you can see it in action. Oh. All right, so I ran it, and let's scroll up. So we can see eval has been called. It's been called. We eventually got to 42. A number was found. I see. We returned 42 up the stack. We added 42 to the environment. So you can see save is equal to 42. Okay. And then we were going down the stack seemingly for the diff expression, where we found the 41. And we're returning that up the stack with the environment. And then I can see some math was done, realized the answer was 1, and then we return that all the way back up the stack, and then 1 is the answer. So let's look at the math statement for that. So we have the let expression, and we know that the let expression has a number of things that are guaranteed to be here. And let's look at the editor, the grammar, so we can definitively say what those are. So we have identifier, which has to be here. We have an expression, which has to be here. And then we have another expression. All right, so those are 3 things that are guaranteed to be in a let expression. One thing to note when looking at the let expression is that given that the identifier and the value that this expression, this one, evaluates to needs to be added to the environment for this expression, this is not going to be evaluated in order from left to right. Instead, we have to evaluate this first and then assign it with this and then pass that into this, like the order of operations wise. So the way that looks is here. So I note this is going to be the identifier expression. This is the value expression, which the identifier equals to. And this is the in expression, like the one at the very end. So first we evaluate to get the value, right? Then we add the identity, the identifier, which we don't have to pass into eval to know its identifier because we know explicitly from the syntax, the expression, that it has to be identifier. So we can just pull the string directly and then pull the value that was returned here and pass that in. And again, I'm parsing it to I32 or converting it to I32 because this language only has I32s. And then after we create the new environment, we pass in the in expression, so the last expression in the expression grammar, to eval with the new environment. And that resolves to what we want it to be, which in our case is a diff expression of 42 minus 41. All right, so we reached the end of the video, and there's a few things I would like to say. Like, I've been programming for a while, and writing, or the idea of writing a programming language, always seemed like a daunting task. But after messing around with pests for a bit, and then going through the book a little bit to understand some of the basics, it doesn't seem that bad or far-fetched, and it's very approachable in Rust. So I just hope that, like, through watching this video, some of y'all just, I don't know, get that confidence that you need to do stuff like this, because it really isn't that bad. Outside of that, if you like the video, hit like, subscribe, yada, yada, yada. Till next time. Peace.